Now, there are other ways of identifying special systems without graphing. So let's just go ahead and take a quick look at how we could have identified these special systems without graphing them. Now let's go ahead and take a look at an example here to see how we can identify these without having to graph them. Now some of the things that you want to use here is what we already talked about in chapter 7 earlier on. Now if you remember, we talked about the slopes of parallel lines, and we said that parallel lines have the same slopes, so you can use that information here also. And of course, with the same line, as we know, they're going to be the exact same line. That means, again, they're going to have the same slope. So how can we go ahead and identify if the system is inconsistent or if the equations are dependent? So let's go ahead and use the idea of our slopes to help us out here. Now, what we will do is take each one of these equations and solve them for y. Get y by itself, and then we can go ahead and use the idea of their slopes to help us out. Let's start with our first equation here. You have 2x plus y equals 6. Again, remember, we're trying to get y by itself. So I will start by moving my 2x over to the other side, which will give me y equals negative 2x plus 6, and you can see our slope right here is negative 2. We'll do the exact same thing with the other equation. X minus 3y equals negative 4. Move your x over. You're left with negative 3y equals minus x minus 4. Divide everything by negative 3, and that will give you y equals 1/3 x. The two negatives will become positive. Same thing here, and that will give you your slope. I guess I'll call this m1 and m2, and your second slope will be 1/3. Now you can see that both these lines have different slopes, which tells me that they are neither parallel or the same line, because if they were parallel lines or the same line, they would have had the same slope. So in this case, this is a consistent system. Your equations are independent, and you will have exactly one solution for your system. Okay, so since your slopes are different, the lines will intersect. At just one point. All right, let's look at another example here. Let's say we have y equals 3x and y plus 3 equals 3x. So y equals 3x, it's already solved for y. You don't have to do anything. You can just look at this and see that the slope of this line is 3. For our second line, you have y plus 3 equals 3x, so we need to move the 3 to the other side, and that gives you y equals 3x minus 3. And again, if you look at the slope of this line, you have 3 as your slope. Now, since both the lines have the same slope, how do we know if the lines are parallel or if they're the exact same line? For that reason, we will look at the different y-intercepts for both of these lines. Now, if you look at the y-intercept on our first line, you can see there is no number after our 3x here. That tells me the y-intercept is going to be at the origin or at the point 0, 0. Okay? Now, if they're the same line, they should have the exact same y-intercept. If they are parallel lines, then they should have two different y-intercepts. If you look at the y-intercept on this line here, our second line, you will notice your y-intercept here, you have the number -3, which tells me your y-intercept is the point 0, -3. So since you have two different y-intercepts, we can conclude that these two lines are parallel. Okay, so both our equations have same slopes, but different y-intercepts. Okay, so we can say these equations have graphs that are parallel lines, and therefore we can conclude that this is an inconsistent system, and your solution set, if you remember, for an inconsistent system is an empty set. So you can see it works out quite nicely if you try and figure out what your solution sets might be without even trying to graph. Now let's look at just one more example. And in this one, we're talking about the system 2x minus y equals 4 and x equals 1/2 y plus 2. We're going to try and do the same thing here, solve each one of the equations for y, look at their slope and y-intercepts, and try and decide what sort of a system we have here, what kind of solutions we can expect. So 2x minus y equals 4. Move your 2x over to the other side. Negative y equals negative 2x plus 4. Now we need to get rid of that negative on the y, so we can divide everything by -1 to get rid of that negative sign, and you end up with y equals, two negatives become a positive, you have positive 2x minus 4. So you can see your slope here is 2, and the y-intercept is the point 0, -4. What happens with the second equation? You have x equals 1/2 y plus 2. We'll go ahead and get y by itself, so let's start by moving the 2 over, which gives you x minus 2 equals 1/2 y. Now we want to get rid of that 1/2 on the y. We can multiply this by 2 on both sides. Okay, so that will get rid of the 2 in the denominator, which will give you 1y, and this gives you 2x minus 4. 1y is the same thing as y, so you have y equals 2x minus 4. Again, you'll see you have the same slope and you have the same y-intercept. And of course, the two equations also look exactly the same. So it's safe for us to conclude that the equations are exactly the same, which means their graphs are the same line. And then we said when you have the same line as your graphs, that tells us we have infinitely many solutions. So your solution set will be again, remember, we use the set builder notation for these sort of equations, and you have, again, use any one of the two equations for your solution set. Okay, so anytime you have the same slope and the same y-intercept, you can say that the two lines are exactly the same, and you have infinitely many solutions. If you have the same slope but different y-intercepts, those lines are parallel and your solution set is an empty set. And if you end up with two completely different slopes, then you know that those lines will intersect at one point and you will have a solution set. For those, you will have to go back and graph them to find that point of intersection. All right, and this will conclude our discussion on section 8.1.